Okay, this is part 2. We're going to talk about raising the quotient to a power. If you look at the first example that we have, xy to the third. Okay, when it's in parentheses, we realize that last time this exponent is going to affect everything inside parentheses. So it means that I'm going to take x to the third power and y to the third power. Okay? So when I do that, that means x to the third, x times x times x over y times y times y. Nothing that I can cancel out, so x to the third, y to the third is my answer. The property then is like if you said a over b to the n power, it would mean that you're going to take a to that exponent and b to that exponent. Our bases are not the same. Okay, so let's look at example 3. We're going to do this kind of quickly because this is a little bit of review. Which equation or which expression is equivalent to this? 4 over x squared to the third. That means I'm taking 4 to the third power and x squared to the third power. Okay? Well, I told you it would be a good idea to know your cubes. So 4 to the third power is 64, and x squared cubed, which means x squared times x squared times x squared. So it's x to the 6. Okay? Which one of those choices is 64 over x to the 6th? And that is choice D. Okay? Just real quick checks. 3 over x squared to the second. 3 squared over x squared squared. 3 squared is 9. X squared squared, 2 times 2 is 4. So x to the 4th. Okay? Looking at this expression down after the quick checks. What happens if I have AB to a negative exponent? Okay? Well, you need to realize that A to this, let's walk through these steps so you can see how it ends up. It means it's 1 over a b to the n power, okay? Which essentially means that when I move it through, and let's say a and b was, let's just say it was 1/2, okay? And let's just say 1/2 was squared. So now I have 1 over 1/2 squared. Okay? So then I have 1 over 1/4. Okay, if you were to do that on your calculator, 1 divided by 1/4, you would find out that that is 4. So essentially what has happened is this has become the reciprocal of that. The result is. So when I have a over b to the negative n power, and I write it like this, essentially I'm saying b over a. I'm taking the reciprocal to that exponential power. And they show you a few more steps there on page 455, but I just wanted to kind of show you a real life example so that you could see why that is true. All right, example 4, simplifying exponential expressions. Okay, we're going to start with 3/5 to the negative second power. Well, since it's a negative power, what happens to my base? it becomes the reciprocal. So it becomes 5/3 to the second power, which then means I take 5 squared over 3 squared, which becomes 25 over 9. Okay, let's try this with some quick check problems here. Let's look at A. Let's try A. 3/4 to the -3rd. Once again, those cubes, negative exponent means this becomes the reciprocal. So 4/3 cubed becomes 4 cubed over 3 cubed. 4 cubed is 64. 3 cubed is 9. You can leave it 64 over 9. No, 3 cubed isn't 9. 3 squared is 9. 64 over 27. Or you can make it into a mixed number if you like. But 64 27 would be fine. Last two examples. Let's look at C and D on the quick check. C is 2R over S to the -1st power. And D is 7A over M to the -2nd power. Okay? Negative exponent, what happens to this? Becomes the reciprocal. So S over 2R to the 1st power. Well, S to the 1st and 2R to the 1st just becomes S over 2R. And then 7A over M to the -2nd. Negative exponent means this becomes the reciprocal. So M over 7A. And then I'm going to square that, which means M squared over the quantity 7A squared, which simplifies to M squared over 7 squared is 49, A squared is A squared. Okay, we did not go over the real life example. You've done those in science dealing with scientific notation. Guided practice. Page 456. Let's look at numbers 6, 8, 22, 30, and 34.